As the introduction said, I'm a software engineer at heart. I've been at Google for 15-ish years now, and I've been doing open source since 1994. I'm part of the engineering productivity team here at Google, and we focus on making Google's engineers more productive. And one of the things that scares us at the moment are these two graphs. These two graphs show that the cost of making hardware goes up as you shrink the process, and the realization of the optimal result is getting further and further away from where it should be. And we see a world where we need faster, cheaper, and more custom silicon, and we don't see needing 10x as much as we're doing today. We see a world where we need 1,000x as much, especially because every workload Google cares about is growing exponentially, and hence we need significantly more silicon to solve this problem with Moore's law slowing down. To help solve this and make it easier for people to explore space, Google worked with Skywater to release a fully open source PDK, which you can clone from GitHub without any NDAs or anything like this. It's under an Apache 2 license. From that, we've built a community which has over 4,800 members. Anyone can join. You can go and join right now. If you go to the opensourcesilicon.dev site, you should be able to join and become part of this community. And because silicon has real costs, Google has been funding a open MPW shuttle program where if your design is open source, we'll basically foot the bill for getting it manufactured. That program's been running for a while now. In the first year, in 2020, we did 45 unique designs. In 2021, we did 200 unique designs. And in 2022, we did 400 unique designs. And the goal for this year is over 1,000 unique designs. Every time we do a run, we do 40 designs at once. This really has significantly reduced the cost to do things in this space and enabled people who otherwise wouldn't have access to silicon to really have success in doing tapeouts. Here's some examples. Here you can also see that because this is all open, you can publish images of their design. This is a design which on our MPW program is another MPW, so it's kind of MPW squared. As mentioned, last year we had Global Foundries join and a 180 nanometer process announced. We also have a collaboration with NIST and a 90 nanometer PDK announced. So if you look at the progress in this space, you can see that these things are all growing exponentially. And we hope to keep those numbers going because we really do see an exponential as the only way to keep up with the demand needed in this space. We have a couple of partnerships with NIST to expand this into areas like cryogenic and nanotechnology. And a lot of this data is being published for anybody to see. So if you want to go and see the results from the silicon, you can actually go and see the raw data. You don't have to ask somebody to get it. We see a future where an ASIC designer is doing their first tape out in middle school, and by the time they go to university, they've got multiple tape outs. This is kind of the same way in the software world where people now, learn to program in, middle and primary school. We think this is enabled through the open source nature and by dramatically reducing the cost. And we have a whole bunch of projects in this space to help make it easier, including doing things like adding AI tuning. Here you can see 1,000 different runs running, trying to tune the performance of a little RISC-V core. And so Google's doing a lot of different things in this space. Here's a link to some of them. I think particularly relevant to this discussion is the XLS, which is Google's high-level synthesis tool, and the CFU Playground, which is a tool about increasing the speed of optimization loop and really tying hardware and software together in a very quick, fast way that has demonstrated 1000x speed ups on you know, application specific solutions.